Okay, this is video 3 of the sections 5.1, 5.2 for matrix solutions to linear systems. And for this objective, we're going to solve a systems of linear equations using matrices. Let's look at example 7 together. Example 7 has a ball being thrown upward. And when a ball is thrown upward, it follows a parabola. And this function, this position function, is modeled by h of t equals 1/2 a t squared plus bt plus c. And h is the ball's height in feet after t seconds. We're going to find the function that models the ball's height as a function of time. Now you may wonder, how do we do that when we're not given the function? What we are given are 3 points on this parabola, 1, 40, 2, 40, and 3, 24. So what that means is we have that h of 1 is equal to 40. We also know h of 2 is equal to 48. And finally, h of 3 equals 24. Using those 3 values, we can write 3 equations. The first equation, we can write it as 1/2 a, our t value is 1 squared, plus b times 1 plus c is equal to 40. This equation comes from h of t. The second equation, we can write it as 1/2 a, 2 squared plus b of 2 plus c equals 48. The third equation is 1/2 a, this time t is 3, so 3 squared plus b times 3 plus c is equal to 24. Let's simplify this a bit and simplify 1/2 times 1 squared is 1/2. Forgot the a there, 1/2 a, and then we have 1b plus c is equal to 40. The second equation, 2 squared is 4, and 4 times 1/2 is 2. So we have 2a plus 2b plus c equals 48. The last equation, 3, this should be a squared, made a typo there. 3 squared is 9, and 9 times 1/2 is 9 over 2. We have 9 over 2a plus 3b plus c equals 24. And there's our 3 equations, and our unknowns are the coefficients a, b, and c. And so we learned in the previous video, we can write this as an augmented matrix, and then just use our calculator to have it tell us what a, b, and c are. So the augmented matrix is 1/2, 1, 1, and then 40. And then we have 2, 2, 1, 48, 9 halves, 3, 1, 24. Okay, let's head over to our calculator to put those in to our matrix. Okay, so we have our second matrix. Go to edit and put in our values. So it was 1/2. 1, 1, 40. Our second row was 2, 2, 1, 48. And then 9 halves, 3, 1, and 24. Okay, quit out. Let me just make sure that it's in correctly, and it looks like it is. So quit out, and then we go to second matrix, go to math, and go to reduced double REF, and call our matrix back, matrix A, and here are our values. Okay, so let's copy that down onto our paper. So our reduced row form is 1, 0, 0, negative 32, 0, 1, 0, 56, and 0, 0, 1, 0. So what does this mean? This means that this is A and B and C, that A, the coefficient A is negative 32, B is 56, and our constant term is 0. Let's now write the function that models this ball's height as a function of time. Remember, pulling h of t, h of t is equal to 1/2 at squared plus bt plus c. So h of t is equal to 1/2 times negative 32 t squared plus 56 t plus c. If we write this again and simplify what we can, we got negative 32 times 1/2 is negative 16 t squared plus 56. I forgot to replace the c with 0. Maybe because our given our c was 0, so it's 56t. So there's our function. And then it asks, what is the ball's maximum height? Going back to how you find a maximum value, we can use or find the vertex, right? Because that's the maximum value of the parabola. And to find the vertex or the t value of the vertex, or I guess we could say x value of the vertex, we use the formula negative b over 2a. And negative b is negative 56. 2 times negative 16, that's negative 56 over negative 32, which gives us 1.75. So this is not the actual height. This is at the time that the ball reaches the maximum height at 1.75 seconds. So using that, we have to plug it back into our function. So h of 1.75, we plug that in to our function. We have negative 16, 1.75 squared plus 56 times 1.75. And that is approximately 49 feet. Okay, so its maximum height is 49 feet at 1.75 seconds. If we go back to the graph here, you can see it does look like it's reaching the maximum height at 49 feet at about 1.75 seconds after it's been thrown. Okay, for example 8, let's do this one in class together. This is going to be a similar problem where it's Bethany invests $10,000 in 3 accounts. So we'll save that for class. And then we have one more objective. There is another way. We looked at process of elimination and then using the matrix function in the graphing calculator. There's also a method called the Gaussian elimination. We'll also talk about this method in class. Okay, I hope you find or found this video helpful. Again, if you have questions or issues, feel free to contact one of us, your professor.